Welcome to Physical Sciences Consultorium. This video is part of the series How We Know the Universe. In this final episode, we ask a simple but important question: what does it actually mean to know the universe? Throughout this series, we have seen that astronomy works with indirect evidence, uncertainty, models, predictions, physical limits. Given all this, it is reasonable to ask what kind of knowledge space science actually provides. In astronomy, knowing does not mean direct access. We do not touch stars. We do not sample galaxies. We do not observe the universe from the outside. All knowledge comes from signals interpreted through physical laws. Indirect evidence is not weak evidence. Light, particles, and radiation carry structured information. When interpreted using physics, they place strong constraints on what is possible. In space science, knowledge is built when explanations remain consistent across observations. Different instruments, different methods, different datasets. The same conclusions emerge. A single observation can mislead. Reliable knowledge comes from repetition, repeated measurements, repeated tests, repeated agreement. Stability over time matters more than novelty. Uncertainty does not weaken knowledge. It defines its limits. By stating uncertainty explicitly, astronomy shows how far conclusions can be trusted. Scientific knowledge grows by eliminating explanations that fail. Models survive not because they are appealing, but because alternatives perform worse. What remains is not certainty, but the most reliable account available. Reliable knowledge produces predictions. When predictions succeed across new observations, confidence increases. When they fail, knowledge is revised. This cycle keeps explanations grounded. Models are trusted because they continue to work. They explain multiple phenomena using the same physical principles. Their success is cumulative, not rhetorical. No single astronomer decides what is known. Knowledge emerges from independent verification, shared standards, open comparison. Reliability is collective, not personal. Some questions remain unanswered. Some limits are physical, not technical. Admitting these limits does not weaken science. It defines the boundary of what is known. Astronomical knowledge works. It predicts behavior. It guides technology. It remains stable under new tests. Reliability is demonstrated by performance. To know the universe means to have explanations that are constrained by evidence, survive repeated testing, remain reliable within stated limits. This is not absolute truth. It is dependable understanding. The universe is vast, distant, and inaccessible. Yet through careful observation, modeling, and testing, we build reliable knowledge about it. That reliability is what science offers. To know the universe is not to possess final answers, but to understand how far our explanations reach, and why we trust them that far. If this way of understanding space science has been useful, this is exactly what Physical Sciences Consultorium exists for. We focus on how scientific knowledge is built. If you found this series valuable, please like, share, and subscribe to the PSC channel.